تمام ان شاء الله. أحسنت.
السلام عليكم.
عليكم السلام ورحمة الله وبركاته بروفيسور.
أهلا، إن شاء الله خير.
فقط كتكنيشن ايشو، يعني أنا كل شيء جاهز، لكن صار الدعم الفني ما قصر ووصلوا لنا.
لا أكيد بلا شك بلا شك.
جزاكم الله خير.
الله يخليك.
ممكن نبدأ مباشرة.
احنا بس نحب نتأكد أن الأوراق البحثية 8 تكون جاهزة، والأخوة المؤلفين يكونوا جاهزين لكي نبدأ.
إن شاء الله.
عندنا بس اجتماع.
أوكي.
كتير جدا بالنسبه للتعليم العام.
اتحاد الجامعات
انا محتاج ان انا اعمل توازن شويه بالنسبه لل
Good day everybody. السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
الحقيقة أنا أعتذر عن التأخير الذي حصل، وهذا يحصل طالما نحن مع التكنولوجيا، وبقدر ما نعتمد عليها فهي في كثير من الأحيان تحاول أن لا نقول تعبث بالوقت، ولكن هكذا يحصل. فإن شاء الله تكون الأمور بخير ونستمر باسمه تعالى. Everything is okay?
Yes, I think.
Okay.
Everything about technician issue, everything is okay, and the videos is ready, so you can start with the presenter.
So can we start now or just wait?
دكتورة ما في وقت.
No, can. Go ahead.
Okay. Welcome everybody for our session, the 5th session concerning the IT society. We have 8 papers to be presented within this session, and in order to commit with the regulation of the scientific committee, we have to spend only 10 minutes with each paper. We will wait 2 minutes for every presenter to present, otherwise we will use the recorded presentation if it's available, or we will pass to the other paper. Our first paper for today is toward the use of telecommunication technology with technical guarantees. This is by Mustafa Al-Mitwalli Kandil from Al Ain University, United Arab Emirates. Dr. Mustafa, are you there?
Yes, I am there. Good morning. Hello, good afternoon.
Yeah, good afternoon. So please, we hope that we will spend the 10 minutes with your presentation and everything will be fine. Please, Dr. Mustafa, you can start right now.
I sent the pre-record before.
Okay.
Yes.
The recorded will start now.
Okay, great.
Good morning. I am Mustafa Al-Mitwalli Kandil. I am Mustafa Mitwalli Khandil. I am a professor at College of Law, Al Ain University, United Arab Emirates, and Tanta University, Egypt. I will share my paper.
Can you share his presentation? Yeah. Stop, bro.
The title of my paper is about towards the use of telecommunications technology and litigation with technical guarantees. In this paper, the paper begins with the introduction and the two main ideas. The first one about the concept of using telecommunications technology and litigation, and the second one about the technical guarantees when using telecommunication technology and litigation. These guarantees are 5. 1, recording, safekeeping, and confidentiality of the records of remote litigation. 2, applying information security policies to remote litigation procedure. 3, the transcription of remote litigation procedures into electronic or hard copy documents. 4, acknowledging the validity of e-documents and e-signature to use the remote litigation procedures. 5, technical guarantees accompany the attendance and the pleading of the parties shall be provided. About the introduction, many countries have taken accelerated steps towards the use of telecommunications technology in the field of litigation. This use compelled the adoption of certain providers.
I'm so sorry for interrupt, but I think there is no presentation before, so we have to back 1 minute before.
Use of telecommunications technology and litigation. Good morning. I am Mustafa Mitwalli Khandil. I am a professor at College of Law, Al Ain University, United Arab Emirates, and Tanta University, Egypt. I will share my paper.
All of you, did you see the presentation?
The title of my paper is about towards the use of telecommunications technology and litigation with technical guarantees. In this paper, the paper begins with introduction and the two main ideas. The first one about the concept of using telecommunication technology in litigation, and the second one about the technical guarantees when using telecommunication technology and litigation. These guarantees are 5. 1, recording, safekeeping, and confidentiality of the records of remote litigation. 2, applying information security policies to remote litigation procedure. 3, the transcription of remote litigation procedures into electronic or hard copy documents. 4, acknowledging the validity of e-documents and e-signature to use the remote litigation procedures. 5, technical guarantees accompany the attendance and the pleading of the parties shall be provided. About the introduction, many countries have taken accelerated steps towards the use of telecommunications technology in the field of litigation. This use compelled the adoption of certain provisions of a number of technical guarantees to protect the rights of litigants. In this paper, we will present the United Arab Emirates as a model in the field of technical guarantees associated with the use of telecommunications technology in the field of litigation. This use has raised some questions. What is the nature of using the telecommunications technology and litigation procedures? What technical guarantees can be offered to the litigants upon this use? Does this system provide guarantees similar to traditional about the non-electronic procedure litigation? About the concept of using telecommunications technology in litigation, the use of telecommunication technology in litigation refers to using the visual and audible means of communications between two or more parties in order to enable the remote attendance and the exchange of documents, which may include filing the claim as well as a different procedure of notification, trial and execution that could all be completed through the using of this technology. Through the use of this technology. About the technical guarantees when using telecommunication technology in litigation, the use of telecommunication technology in litigation shall be based on providing the litigants with a number of guarantees. We will mention first one, recording, safekeeping, and confidentiality of the remote of the records from remote litigation. The records of remote litigation are recorded and saved electronically. These records have the legal capacity of confidentiality as they may not be circulated, reviewed, copied, or deleted from the electronic information system of the court unless by a permission issued by the competent court. 2. Applying information security policies to remote litigation procedures. The telecommunications technology used for litigation procedure is subject to the adapted regulations and policies of information technology in United Arab Emirates. The information security here refers to providing protection to the content of data and information for the remote litigation procedures against any attempt to change, modification, or forgery during the different stage of exchange judicial documents and papers electronically. No third parties may have access to any of this information, as access to this electronic information system shall be limited only to certain authorized persons, such as judges and their assistants, lawyers, and the litigants. 3. The transcription of remote litigation procedure into electronic and hard copy documents. It could be required to transcribe the remote litigation procedure into the hard copy form, such as printing a hard copy for a judicial request, or should be concerned parties request a hard copy for the claim documents. The legislator has confirmed that the competent authority shall transcribe the remote litigation procedures into electronic or hard copy documents that could be approved without the need for any authorizing signatures by the concerned parties. 4. Acknowledging the validity of e-documents and e-signature use the remote litigation procedure. To use the telecommunication technology for litigation procedure, it is required to have the litigants' signatures or to exchange the documents electronically. The legislator has granted both the e-signature and e-documents the same validity as a conventional signature or the official and customary documents. 5, and the last one, technical guarantees accompany the attendance and the pleading of the parties shall be provided. The legislator stipulates the following obligations when using the telecommunication technology in order to verify the attendance and the pleading of the party. The competent judge shall determine the hearing date and hour accurately. 2. The claims management office shall inform the concerned parties electronically of the remote hearing date and hours. 3. The competent technical officer shall prepare all devices used in the remote litigation or remote trial will. In addition, He shall be able to respond quickly in any cases of technical malfunctions or interruption during the hearing. 4. The appointed lawyer shall be fully prepared regarding the necessary technical knowledge as well as the use of different devices which enable him to communicate with the supervising judge or the competent court. 5. The hearing proceedings shall be recorded. As a conclusion, the UEA legislator has permitted the use of telecommunications technology in the litigation procedures before the civil court. A number of guarantees are provided for this new use as follows. 1. The remote litigation records and their confidentiality are safe. 2. Information security policies are applied to remote litigation procedure. 3. The remote litigation procedures are transcribed into electronic or hard copy documents. 4. The validity of e-documents and e-signature is acknowledged. 5. Technical guarantees accompany the attendance and clearing of the parties shall be provided. Thank you.
Thank you, Dr. Mustafa, for your presentation, and thank you for committing with the time. In fact, it was a very well organized paper that presenting the concept of using telecommunication in litigation based in providing the litigants with a number of guarantees similar to that of traditional litigation procedures, including the remote attendancy, e-signature, and e-document. Now we have to go with the second paper, and the second paper for Noura Al-Raisi from Sultan Qaboos University in Oman, and it's about the characteristic of the intellectual output in the field of big data in Oman from 2010 to 2020, applying the bibliometric approach for analyzing the data. Please, Noura, the time is for you, and please let us commit with the 10 minutes because of the time, lag, and besides that, we have another session after our session. So, Noura is there?
Yes, I am there.
Okay, Noura, you are mostly welcome, and I'm happy to hear from you in this session.
First, I would like to thank the Prof. Naima to manage this session. Today, inshallah, I will present my research, which is about the characteristic of intellectual output in the field of big data in Oman from 2010 until 2020, bibliometric study basic on Scopus. First, the big data described as
Excuse me, Sister Naima.
Yes.
Do you have presentation, or you need to show the video, or how you can do your present?
Don't have any presentation yet. I'm waiting to see.
Yes, waiting to see the
presentation.
All right. The video presentation, or she will.
The video. The voice is clear, very well.
All right. So let's start. Share.
Okay. Okay.
Now it's okay?
Okay, please.
All
Go
right.
ahead, please, Noura.
In the field of big data in Oman from 2010 to 2020, bibliometric study basic on Scopus. Big data described as a complex form of data that cannot be sorted and processed by traditional data management tool. Researchers have been interested in the big data field to study the importance and use of big data and other important aspects related to this subject that lead to increase the intellectual output
and to measure the intellectual output in any field needs to conduct bibliometric study. The importance of these studies to identify the trend in scientific research and the gap in science, as well as measuring scientific progress. Therefore, big data research has become quite popular in this period. In Oman, the Oman Vision 2014 focused on the role of the fourth industrial revolution and digital transformation. On one of these important technology is big data. This promoted many researchers interested in the field of big data to conduct study based on the direction of the vision, as well as lead the researcher in the present research to try to identify the intellectual output, trying to know the level of research production in Oman. Therefore, this study trying to answer the question, what are the characteristics of intellectual output in the field of big data in Oman from 2010 to 2020, according to type of document, year, organization, and author, subject area, and language. To achieve the aims and answer the research question, the research applied bibliometric approach by using Scopus databases. The study covers the published intellectual output in the field of big data in Oman during 10 years, which was indexed in Scopus databases. The result of research, document by type. Document type is divided in 4 types: article, book, chapter, review, and conference paper. The highest type of document was conference paper, about 103. The lowest type of document was review, about 3 only. Document by year. The number of publishing from 2010 until 2013 was 0. The chart shows that there are up and down research growth in the field of big data. In the year 2016, the highest, and the year 2014, the lowest. Document by type. The universities and colleges are the most productive in the field of big data. The document by author, academic staff who work in universities and colleges in Oman, more productive in field of big data. Document by subject, the highest percentage of document was in computer science, followed by engineering, then social science, where the lowest was in medicine and environment science. Document by language, all the intellectual was written in English. So this is the end of my presentation. My name is Noor Risi.
Done.
Thank you, Safir. The presentation, please.
You need the presentation?
No, still it is cut.
Not cut. I think the time is done. 4 minutes, 22 seconds. That's all.
Only 4 minutes? No, that's impossible.
So we are
have
the recommendation, and after that it shifted to the conclusion. Okay. That's all.
Okay. I wonder if Noura is there. Is Noura still there? Okay, she is not there anyway. We usually, students, they use the bibliometrics to analyze the data or the big data from Scopus, and the Scopus only limited to data published in journals accepted and listed in Scopus. And that sometimes give us a short idea sometimes, or limited idea. All what she analyzed, Nora, is 123 articles appeared in Scopus. I hope Nora is there, but since she is not there, so we have to go to the third paper. The third paper by Dr. Ahmed Samhan, Suhair Hassan, and Muhammad from Al-Zarqa University, Jordan. And please, are they?
أنا موجود. السلام عليكم.
أهلا وسهلا دكتور أحمد.
أهلا وسهلا فيكم.
And I'm happy to see your name appear in 2 papers today with my session. So
شكرا جزيلا.
we will be happy, but as the time limited to exactly limited time for the presentation, so we have to use it for the presentation better than give more notification. Dr. Ahmed, please, you can start your presentation within the time limit.
So هل راح تشغلوا الفيديو أو أعمل لايف presentation؟
It's up to you if you like.
بنشغل الفيديو عشان نتحكم في الوقت.
ماشي دكتور، ماشي تفضل.
الآن ظاهر معكم جميعا. Did you see the presentation?
ظهر. Okay. Yeah, it's about adopting Riva approach 2 from Dr. Ahmed Samhan in order to enable modeling business process architecture driving from multiple heterogeneous sources of knowledge. Please let us start. Let us start with the presentation.
Greetings. This is Dr. Ahmed Samhan welcoming all of you today on behalf of myself and my colleagues. For this session, I'm presenting an overview of the paper, Adapting Riva to Support Case Strategy Processes and Enable Modeling a Generalized Business Process Architecture. A business process architecture is an organized overview of business processes that specifies the relations which can be accompanied with guidelines that determine how these processes must be organized. Riva is an object-based business process architecture modeling approach where business process architecture is designed by studying business entities or objects as well as the dynamic relationships between them. When we say an object-based, this means that the foundation of deriving the business process architecture models is based on defining objects. In this case, is defining business objects called essential business entities. In any business, there are things or entities that one cannot get away from. They are there simply because of the business the organization is in. These entities are the subject matter of the organization business. For example, an account for a banking business or a module for academic business, and so on. Riva heavily depends on the engagement of stakeholders who are related to a specific organizational business boundary. Therefore, Riva is considered a facilitated approach, meaning based on interaction with stakeholders, which is the opposite to independent approaches. Also, it does not take into consideration the elicitation of the essential business entities from various heterogeneous sources, as it is limited to the sources that belongs to a specific organizational boundary. As a consequence, the resulting Riva business process architecture models are deemed to be confined to the specific organizational boundary used for modeling the business process architecture, rather than a generic one. Also, while generating processes from the identified Riva essential business entities, Riva seeks to identify case processes, case management processes, and case strategy processes to capture views that support the operational, tactical, and strategic management levels. However, Riva literature primarily supports modeling the case processes, case management processes, and the interrelationships between them, but does not address the modeling of the case strategy processes or their associated relationships. This study proposes an adaptation to the Riva business process architecture modeling approach in order to address the mentioned limitations. It adapts RIVA to facilitate the identification of business processes, not only based on the direct interaction with stakeholders within a specific organizational boundary, but also by utilizing independent elicitation techniques of entities from several heterogeneous sources, for instance, documents and standards analysis. Furthermore, the proposition extends RIVA to represent the corresponding case strategy processes and their relevant relationships in order to support the strategic management level view. In the original RIVA approach, if we want to perform this approach, we need to conduct some steps, starting with determining the organization business and boundary, its specific organization business and boundary, then brainstorming the essential business entities from stakeholders within the specified organizational boundary. An essential business entities list resulted from this step. Then filters are applied to the essential business entities to identify units of work, which are the entities that the organization needs to manage its lifetime because of the nature of the business. A list will result from that, a list of units of work. Then dynamic relationships are identified between these units of works to depict a unit of work diagram. Then hypothesizing basic processes like case process, case management process, to produce a first cut process architectural diagram. Then filters will be applied to the first cut process architecture diagram in order to produce a more compact and more realistic process architecture diagram, which is called second cut process architecture diagram. In this work, adapted steps were proposed. First of all, determining the organization boundary and business, rather than confining the business process architecture to a specific organizational boundary, an adaptation is proposed that considers the functional area that has to be modeled operates inside an existing or virtual organizational boundary. This proposition adds more flexibility to an investigated area that needs to be considered for modeling the RIVA business process architecture. For the second step, the RIVA step is proposed to be adapted into two sub-steps. First, to determine the various sources of knowledge that needs to be investigated, and secondly, to extract and filter the candidate essential business entities from each of the selected knowledge sources. The third step here, in the original one, was adapted into three steps. Therefore, rather than combining the units of work list from a single source, brainstorming essential business entities from stakeholders, the adapted approach enables the units of work to be derived from various sources of knowledge and proposes a consolidated set of units of work that facilitates generalization and agreement. After that, a first or units of work diagram is produced based on the consolidated set of units of work diagrams and the dynamic relationships between them. Then in the next step, instead of hypothesizing only case process and case management process, a proposition to hypothesize a case strategy process as well to be added to the first cut diagram. Then heuristics will be applied taking into consideration the case strategy process in order to produce a second cut process architecture diagram. Building on Oates' proposition regarding the case strategy process concept, Oates is the author of the RIVA approach. It had been concluded that every case strategy process has an associated case process and case management process to maintain a strategic view of each of them. Based on that, the case strategy process investigates the internal and external environments of a unit of work and govern the associated case process and case management process. This is the proposition of this paper. By the following relationships, directing the case management process and guiding the work of the case processes in a way that fulfills the adherence to the strategic view. To depict that, these relations were proposed in order to represent the case strategy process and its interrelation with the case process and case management process within the first cut process architecture diagram and the second cut process architecture diagram. Business process architecture and business process modeling experts, in addition to requirements engineering domain experts from the University of the West of England, King Hussein Cancer Center, and Airbus, have participated in the validation of the proposed adaptation to the RIVA-based business process approach. During the validation, a case study was used to demonstrate the proposed RIVA approach, which it was about generalized change management business process architecture models. Then the proposed RIVA concepts, along with the conducted case study, were discussed and investigated using an extensive walkthrough-based questionnaire through a semi-structured interviews with the domain experts. Experts were in an agreement with the propositions. In addition, a feedback on the relationships between the case strategy process and related processes was considered to improve the representation of the interrelationships within the models. The RIVA business process architecture modeling approach has been extended in this research to support developing generalized business process architecture models for a functional area that are not limited to an existing physical organization boundary. The proposed extension enables practitioners to use the RIVA-based process architecture modeling approach as a facilitated and/or independent elicitation technique and supports the elicitation of the essential business entities, which are the foundation of the RIVA business process architecture models, from various heterogeneous sources like stakeholders, standards, policies, procedures, models, etc. Instead of being limited to only one source of knowledge restricted to one physical organizational boundary, which is brainstorming sessions with the specific organizations related stakeholders. Having generalized business process architecture models that are driven from multiple sources facilitate reaching to a consensus amongst different parties related to a functional area, which also enables reaching to a standardized set of processes. The RIVA approach has been extended to identify and model the case strategy process concept and its relationships with other related processes. This extension enables supporting the strategic management level related to a functional area of interest, which was not supported by the existing RIVA literature. Thank you for your attention.
Thank you, Dr. Ahmed, for making the RIVA concept clear to me as being a business process architecture modeling approach which share business process and software engineering domain. And because of the time, I really enjoy the arrangement of the concept and the paper of your presentation. Thank you very much.
Thank you, Doctor.
Now we go to paper number 4 about an adapted ontology for generalized RIVA, back with RIVA, deriving business process architecture, and back with Dr. Ahmed and Suhair. And I think also the presentation, but I hope the presentation will be within the 10.
Yes, the second one is shorter than the first one.
Hopefully. Okay. Okay, thank you. So I really enjoy it, but the time.
Thank you. Yeah.
Now with the 4th presentation. Yes.
Greetings. This is Dr. Ahmed Samhan, welcoming all of you today on behalf of myself and my colleagues. Today, I'm presenting an overview of the paper, An Adapted Ontology for a Generalized RIVA-Driven Business Process Architecture. A business process architecture is defined as an organized overview of business processes that specifies their relations, which can be accompanied with guidelines that determine how these processes must be organized. RIVA is an object-based business process architecture modeling approach where the business process architecture is designed by studying business entities or objects, as well as the dynamic relationships between them. When we say an object-based, this means that the foundation of deriving the business process architecture models is defining objects. In this case, is defining business objects called essential business entities. In any business, there are things or entities that one cannot get away from. They are there simply because of the business the organization is in, like an account for a banking business or a module for an academic business. To perform RIVA, many steps need to be conducted, starting by determining the organization business and boundary, then brainstorming the candidate essential business entities with the stakeholders and filtering them into essential business entities lists, then identifying the units of works. Units of works are the essential business entities that their lifetimes need to be managed because of the nature of the organization business, then presenting the units of works and the dynamic relationships between them in units of work diagram, then hypothesizing basic processes for each unit of work, like the case process and case management process, with the relationships between them to produce a first cut process architecture diagram, then applying filters on the process architecture diagram in order to produce a more realistic and more compact process architecture diagram, which is called second cut process architecture diagram. Ontology is considered as a formal abstract representation of a domain-related concepts and the relationships between them. The literature shows a number of reasons why using ontologies, such as facilitating reaching a common and shared understanding of a domain or of interest, or providing formal representation of the semantics, or providing a means of resolving semantic heterogeneity detected in a domain knowledge. Generally, an ontology mainly consists of classes, properties, axioms, and individuals, where classes represents concepts, properties represent roles or relations or data types, axioms represents rules or role restrictions, and individuals represent specific case or object of a defined class of an ontology. We have the SRBBA ontology, which is Semantic RIVA Business Process Architecture Ontology component. It's an abstract ontology that conceptualizes the RIVA business process architecture elements and sets the relationships between them. The SRBBA is composed of a hierarchy of concepts, each with its own set of attributes, as well as set of axioms that are used to produce the units of work diagram, from which the RIVA process diagrams are derived later. By applying the SRBBA stages, the SRBBA will semantically represent and execute the phases of the RIVA-based methods. RIVA is not acknowledged as an independent elicitation approach and does not facilitate the extension of essential business entities from multiple diverse sources from inside and outside a specific organizational boundary. RIVA literature focuses on representing the case processes, case management processes, and their relationships, but not on representing or presenting the case strategy processes or their related dynamic connections. Accordingly, the Semantic RIVA Business Process Architecture Ontology component was developed to semantically enrich and formally characterize the original RIVA approach and its driven business process architecture model. This semantic enrichment, however, was confined to RIVA's original features and does not address the mentioned limitations. For the aim of this study, the suggested elements of the case strategy process notation modeling and how they may be translated into the first and second cut process architecture diagrams are addressed. Consequently, additions and or updates are suggested for related classes, characteristics, swirl, and gist rules. When we say gist rules, it's It's Java expert system shell statements, and the Swirl is semantic web rule language statements. Here are some examples of how an adaptation was conducted with regards to the SRBBA ontology component. Some concepts were added or updated, some properties were added and updated, and axioms were added or updated, together with the addition or updating the GIS rules in order to add the case strategy process notations. Here are some relations that were taken into consideration in order to represent the case strategy process and its relations with the associated case processes and case management processes. And these are examples of how it was conducted in order to adapt these into the SRBBA ontology components. Also, by supporting semantic heterogeneity resolution by adding a property that's called has synonym or has synonym. It is a data property which has the domain unit of word concept and the range string. The has synonym property may be created with values representing the many synonyms found for a certain unit of word. This is an example of how it was done through the Protege tool that it was used to semantically enrich the SRBB ontology component. And for the evaluation, different criteria such as consistency, completeness, and redundancy was taken into consideration for the evaluation of the extended SRBBA ontology component. Many verification techniques like using the Protege reasoners or conducting checklist-based walkthroughs in order to check these criteria for the ontology component. This is an example of using the reasoner to check the consistency, and this is the example of using the walkthrough checklist in order to check the completeness and redundancy for the components. The SRBBA Riva BBA modeling approach has been extended in this research to derive the anticipated business process architecture models from various sources of knowledge and support resolving semantic heterogeneity. Therefore, concepts, axioms, swirl, and GIS-based rules that expand the representation of the case strategy process notion have also been developed. Utilizing the adapted SRBBA enables practitioners to develop generalized business process architecture models for a functional area that is not limited to the existing physical organizational boundary. In addition, it enables representing the essential business entities from various sources instead of being limited to only one source of knowledge. Moreover, the adapted of SRBBA ontology enables an improved shared understanding between various stakeholders by supporting mapping between the heterogeneous terminologies of the identified essential business entities and the identified units of work. Thank you very much for your attention.
Thank you very much, authors of the two papers. In fact, the two papers, discuss an area which really made me very enthusiastic to read more and more about Riva and the sources of data for applying Riva architecture. Thank you, Dr. Ahmed, for presenting the two papers, and thank you all for that.
Thank you.
Assalamu alaikum.
Wa alaikum salam, Dr. Salam. Thank you so much. I'm so sorry. I wish I could see you and discuss more if we have more time, because he is really very interested, and I'm truly go to the papers and read it to find out, exactly. But the presentation makes it very easy for me about that. Thank you so much for that, and we will see if there is any notification or question at the end of the session. If we have time, then we will be
Inshallah. Yeah, I just wanted to thank you, Dr. Naima, for managing the session, and thanking Dr. Ahmed Samhan for presenting on behalf of both of us.
Exactly.
And I think we can, I hope we can meet later to discuss it further. Thank you very much for your interest.
Yeah, we pay for the delay of the previous session. Now we have the fifth paper, which been prepared by 10 authors from Ghana, University of Energy and Natural Resources. And from this paper, we expect to see how the authors try exactly to explore the topic of enhancing flood prediction and how it put together hybrid repos robust machine learning technique to implement an effective flood prediction model. Please, I don't know who of the 10 authors will present the paper, but let us start, and I hope the presentation comes back at the time.
Hello?
Hello, yes?
Yeah, Dr. Isaac Kofinti will do the presentation. Hello?
Thank you, Dr. Isaac. You can go ahead, please. Thank you for presenting the paper.
Can I share my screen, please?
Yeah, do. I think the committee preferred to put the recorded presentation in order to commit with time.
Okay, then it can be played.
Yeah, so at least to present the whole paper rather than, use the time for sometimes not necessary. So it's better to use the recorded copy, please.
Okay.
Yes, thank you so much. Thank you so much.
Okay.
Can we play now?
Yes, please.
Okay.
Miss Dr. Usina Boatin, Dr. Samuel Boatin, Dr. Miss F.U. Bauer, P.R. Agbenu, S.E. Awari, P. Nimbe, Professor Wallace Adekoya, Dr. B.A. Oyori, and Ms. Vivian Akoto Ejapon. Today, our paper is on enhancing flood prediction using ensemble and deep learning techniques. We are from the Department of Computer Science and Informatics, Waste of Energy and Natural Resources, and from Africa Center of Excellence in Internet of Technology, University of Rwanda. Today, the presentation will look at the introduction, the study objective, the methodology, the results and discussion, conclusions, and future works. So flooding is one of the deadliest natural disasters that is affecting a lot of lives worldwide, causing fatalities and irreparable damage. In fact, flooding is causing loss of human life, and flooding is affecting both developed and undeveloped countries. Among the various types of natural disasters, in fact, flooding is rated the most largest, especially in Africa and other developed countries. So the image here shows flooding incidents in Ghana. You can see that it's a total flood where people have to park and cars not moving. Also another 1 year. In fact, over the 50 years, the country is losing almost about $780 million due to flood. For the past 10 years, every year there is flood in this country. And also in developed country, there are flood happening in London and also in Germany. So I see flood happening in London, cars are not even moving. So flood is a case that all aspects of life, all developed countries and undeveloped countries are facing this. Machine learning and deep learning have contributed significantly over the last few decades to provide improved accuracy and economic solution to stimulate physical flood process. People have tried to use ML to predict flood. For example, Intel use LSTM with daily discharge and rainfall as input data to forecast the river basin 1 day, 2 day, and 3 day flow rate in Vietnam, and then they obtain measure accuracy measures within the values of 95, 99, and 97. Likewise, Intel utilize extreme gradient bushing as the boost model for rainfall around with hourly and daily discharge between 1987 to 1998 data set. And they at the end of the day, the study reported that XGBoost model outperformed random forest and support vector machine. And Mobley Intel also use a random forest to predict flood incidents. So and reported an area under curve measure of 0.895. The objective of this study is to put together a hybrid, robust machine learning technique, that's LSTM
SGBoost, RF, and extreme extra trees to implement an effective flood prediction model. We compare their prediction ability and pick the best model as the final model using historical data of rainfall and water levels from Ghana. We selected these models due to their abilities as discussed in literature, and also they being newly applied in flood prediction in Ghana. But if you look at literature, little or none is done on flood prediction in Ghana using ML. It is satisfactory for regional and metropolis scale application. It relies mainly on historical data set instead of rigorous field investigation. This study is among the few studies to combine environmental factors from developing countries such as Ghana and machine learning algorithms to develop internet flood models to help stakeholders make informed decisions. But the country Ghana have suffered from flood for a long time, and we believe that this study, being the first one, will benefit stakeholders to make informed decisions, and then it's going to contribute to the scanty literature on flood prediction in developing countries. So, and this the big here shows the study framework. So we have our data set, and then we pre-process the data through some pre-processing techniques. We split the data into two: training and testing, and then we train the selected models, select the best performer user as the final model, and then make predictions with that. So we have the data gathering where we downloaded the data from the Ghana Meteorological Service, and then we pre-process the data, try to mixing value, placing the mixing values with average, and second, we normalize the data, scale it using the maximum minimum function so that all the data will fall between 1 and 0, and then we also divide the data into two and build our models and train the models. The data set, the 80-20, the training set was 15% out of that. 80 was also used for validation. So these are the hyperparameters of our models for the LSTM, for the extreme gradient boosting, and from the random forest and from the S3 classifier. All these parameters were not just habitually selected, but however, we use the grid search algorithms to obtain these hyperparameters. And then we validated the model performance using 6 well-known metrics as the mean square error, the root mean square error, the mean absolute percentage error, the R square, and the mean absolute error. So after training all the models, we completed their performance. So the results here shows that the RF, in terms of the mean absolute error, the RF was the best, same as when it comes to the mean square error. But don't forget that it is well to know that when it comes to error, the model with the least is what we are looking for. So from here, we can say that the LSTM performed better as compared to all other models. And in the same way here, the LSTM did best. And when it comes to the R square, the LSTM also did best. So from this diagram, it's clearly that the LSTM is doing good. The SGBoost is also doing very well as compared to the RF and the ET. The LSTM and the SGBoost are better outperform the remaining models as shown in fig here. In conclusion, flooding is a global issue affecting different countries, especially developing countries like Ghana, with at least one flood instance in major cities like Accra and Kumasi every year. We suffer from these flood incidents every year. In this study, we aimed at enhancing flood prediction models with ensemble and deep learning. The obtained experimental results as presented shows that the SGBoost offered a better prediction than the random forest, the extra trees, and then the LSTM. However, with a careful examination of the model's performance as discussed earlier, each method used in this study has some weaknesses, which we believe a combination of 2 or more of these models as a single prediction model with more robust ensemble technique like StackNet can significantly reduce the prediction error. So this is our reference. Thank you.
Thank you. Thank you very much for the presentation and the clear PowerPoints that you present for a very interested topic. And this is really very important, to find the technique that help implementing an effective flood prediction model to help developing countries and save the problem of a flood and or the rare of the water. So it is very nice in this session that we have very, very interested topics, and wish you good luck for more on working on that model and use the data analysis in that prediction for the flood. Thank you so much, and we need to transfer to paper 6 because we have also limited time. And the paper 6, we have a group of paper team from Zayed University, University of New Zealand, and Al Ain University. And we expect from this paper to explore the growth of smarter cities and the suggested solutions to the effective management of energy in industry. And still we committed to the recorded presentation just to be safe that we are committed with the time. So please, can you start the presentation? هلال ممكن أن نبدأ العرض لطفاً؟
نعم يا دكتورة، نعم أنا جاهز معك على الخط.
أحسنت.
All right, inshallah, let's move.
Assalamu alaikum. Good morning, everyone. Me, Haj Shaiba, and I'm assistant professor at Zayed University, along with my co-authors, Mr. Nabil Adam from Transpower New Zealand, and assistant professor, Dr. Mohammed Dawood from Al Ain University in Abu Dhabi. We are today presenting our paper, which is about proposing a smart energy meter for a smarter city, which we are targeting here, Abu Dhabi. And that's why the title is Towards a Smarter Energy Meter for a smarter city. But it's from a user's perspective. So we need to learn what really catch users to use smart meters and what variables, what factors impact their decision or their intention to use those smart energy meters. So basically, here's our guidelines for the presentation. It's about describing what are smart meters, what does the literature tell us, and then what are our aims, the methodology, the main findings shown in one tested and validated model, and we then conclude with some limitations and future work. So basically, you can see in this picture, it's the differences between the traditional meters that's here on the left and the smart energy meters with the IHI, with the in-house interfaces, okay? And those one are the smart ones. So it's definitely different. Those smart meters can not only record the energy consumption, but could monitor, estimate, control, analyze, and also predict the energy consumption in a real in a real data, in a real time. Okay, so it's renewable energy sources. It's not, by the way, not only for electricity. It could be for water or for other energy sources. It's definitely one of the main factors of reducing the power consumption by monitoring and estimating the consumption. You can also check the hourly pricing to customers, so not showing only in watts, but in dirhams or in the currency, the current currency. You can also switch between energy suppliers if you feel that tariff or the subscription fees are less in other supplier. You can also shift from those peak times to other times, as happening in Europe. And other models like in Hong Kong, you can also do the demand balance and mitigate climate change by turning on, turning off some of the devices based on the readings of that smart meter. meters. And this is kind of the environmental aspects of those meters. As part of our study, we did a comparative of the most popular 4 smart energy meters worldwide, so that we can get the advantages out of those models and probably skip those disadvantages when considering to develop a smarter energy meter for our city, Abu Dhabi. So I leave you here a little bit with the table, which shows the main specification of the 4 models: the Italian, Switzerland, North American, and Swedish. And then what are the main advantages and disadvantages for each? Like, for example, for the Italians, it's low cost. However, it's like it's not 100% real data, okay, because it shows the rates every 15 minutes, okay, which is, I mean, which is still good, but it's considered like it's advantage for this model. Like for Switzerland, you can have those prepaid options, but there is some security issues associated with this model, and so on. So we reviewed the literature, we had those comparisons, and then what is the case in the UAE? In Dubai, yes, in DIWA they are applying the smart meters, okay? However, not yet in Abu Dhabi. So we are looking for one. We have a smart city. It's a small city called Nazar. It's really smart. And from there, it could be the starting point to launch the smart energy meter project. There is large residential loads, especially in Reem Islands and those big towers and like Al Corniche Road and so on. We need this in-house displays for electricity usage, and we need also to consider the security and privacy consumption trends when it's all about smart energy meters. So what's happening there in the literature, that most likely, most of the time, previous studies, traditionally examining the acceptance of smart energy meters by either following the TAM, Technology Acceptance Model, or the TAUT, the usage, technology acceptance and usage theory. We are now having it in a different way. We are now focusing on what are the perceived benefits that could influence people's intention to use those energy meters. And we are here highlighting the 4 main perceived values: the emotional, environmental, systemic, and monetary. How do they feel about it? What's the environmental and the green aspects of using the smart energy meter? What's the knowledge, the experiences? What do they hear, and how this could impact their perceptions about this, and whether it has any monetary value, like saving money or so. So it is a multiple regression model where we need to see how those are linked and how this can affect users' acceptance towards using those smart energy meters. Here are the definitions of all the variables. The methodology, it's a quantitative. There was an online survey with 15 items. They should be like Emirati residents older than 18 and have enough or sufficient knowledge of the smart energy meters. Online surveys was shared or were shared through LinkedIn and other social media groups. We collected 266 usable responses, and starting for the confirmatory factor analysis, we used smart pillars. Jumping directly to the research model, as promised here, here's the multiple regression model that shows that all those paths are significant. And we may start from here, that the environmental value has significant influence on the epistemic, which means, yes, people do care about environment, and this careness about environment really drives their awareness towards using those, or to have the intention to use those smart energy meters, which is also a significant influence. By the way, those on the paths are called beta, and whenever they are over the 0.1, okay, then it should be significant. And here's the items of the survey, by the way. This is done through the smart PLS software for the regression. Also, the environment can drive the emotional value, okay, which makes those people that the UAE residents are emotionally connected to this technology and wish to use it, like to use it. They have the attitude towards using it, which is also influenced by the monetary value, which they also, it seems that they do care about saving some money by monitoring and controlling their energy consumption, which is also, they like the idea and then wish to use it. And it also has a direct link between the monetary and the intention to use it. So from this model, it seems that those perceived values in an environmental, systemic, monetary, emotional has either direct or indirect impact or influences on the people's intention to use smart energy meters here. Some other statistics could be found here, like the item loading. See that all of them are above the threshold of 0.7, and also for the Kronbach alpha, they are all above the 0.7 threshold, and the cutoff point of the average for the average variance estimated, it's also the same, should be all over the 0.5 cutoff point. So all constructs are valid, all constructs are reliable, and here clearly all paths are shown to be supported as the p-values are less than 0.05 based on the 95 confidence interval. So people do care about the environment, the money, the saving are coming out of those energy meters. They need to know how it works, and they need to try it, and they need to have some good feelings about it. This will result in the intention towards using it. Some of our limitations, basically, the survey that is in nature prone to some measurement error or some biases. However, to deal with this, actually, we employ the 3 academics to review the survey, make sure that it's neutral and the phase validity is achieved. And also the items were borrowed actually from the Internet of Things literature and has been used before. For future work, I think we need to use this model like in other Middle Eastern and Arab, probably Gulf-based countries, to see whether we have the same results. And we think that the culture factor needs here to be investigated to see whether it has a significant either direct or indirect influence on using those smart energy meters, because culture is very important. This is pretty much it for the questions. Looking forward to hearing your questions and our discussion later, inshallah. Thank you so much for your hearing. Thank you for listening.
Thank you, colleague, for this presentation, which is really a very interesting presentation and topic from the emotional point of view. I am myself will be very happy if I have a smart meter in my house to manage the consumption of the energy, because I have to pay for it. It is very interesting area, and I hope we have time for discussion, but the time is very limited and the number of papers are very great. We have now paper number 7. In paper number 7, we have a team from Islamic University Lebanon, from Lebanon, and this team will propose an Android mobile application concerning COVID-19 tracking application, and they call it CATUP, expecting from this model to alert users based on social distance. And we want to see how this model will alert us to get rid of what make our life sometimes very dark, but with the hope we will be happy, inshallah, to get rid of it. Please, I would like to have also the recorded copy in order to commit with time, so we will have time for the last paper soon. So ممكن تشغل لنا رقم 7 please.
ممكن، بس أتوقع أنه هو غير موجود. يعني ما استلمنا منهم تسجيل.
طيب خلينا نشوف إذا كان المؤلفين موجود، علي مقداد وجمال حيدر وجوليا ووليد. أحد منكم موجود للعرض بليز؟ سوري إذا ما كان عندنا الريكوردد وما كان and they are not available, we can go to the last paper. Last paper, also from the Islamic University of Lebanon. It is about using machine learning K-mean approach. موجودين الأخوان؟ موجود معنا الدكتور محمد عياش وحسين كنان، فممكن الريكوردد. هلال هل الريكوردد موجود؟
أيضا دكتور الريكوردد غير متاح.
طيب هل موجود أحد؟
لا يوجد تسجيل للفيديو. لا
يوجد تسجيل. لطفاً هل يوجد أحد من المؤلفين الأربعة للبحث الأخير؟ أنا ما أشوف أحد داخل على الخط معانا. ننتظر دقيقة أيضاً ونشوف. In fact, in the 1980s, many dissertations been written about the interdisciplinarity of information science with other disciplines. And it was found that medicine, engineering, computer, business are the most related domain applying information. But if we repeat these researches today, we will find that many other domains being interested. As we see today, we have people from energy, and we have from flood, and we have adapted ontology for river and business and other, and even in law and litigation. So we have different areas that, in fact, involved in information. Our papers, the 6 papers being done, and if any of the authors are there and they would like to add anything, we have a couple of minutes to use. Otherwise, we'll end this session for today. So anyone would like to add or to? No question, nothing. I didn't find any raised hand. Maybe people are even go to pray or go to sleep. The afternoon sometimes will be very difficult, but I'm really interested in all the 6 papers being presented, and I'm lucky to hear them, and I'm lucky to hear something new to my mind. So if there are no one will interfere or have any notification or any discussion, we simply end the session of today. And I'm glad that we end the session with the recorded presentation, so we commit with the time rather than we take others' time. And thank you for the committee, the conference scientific committee, the technical committee. Thank you very much, Hilal, for your support all the time with us. Thank you for being patient to us. لصبرك وجهدك معنا، وشكرا للجنة العلمية، وشكرا للجنة التقنية، وشكرا لكلية الآداب وقسمي الرائع بما فيه. أنا مسرورة جدا أن أكون بينكم، ولكم كل الشكر على إعدادكم وجهودكم، وأهنيكم على هذه الجهود وبارك الله فيكم.
شكرا جزيلا دكتورة، وهذا
سعدتم مساء والحمد لله على كل شيء.
شكرا جزيلا. شكرا دكتورة نعيمة. شكرا دكتورة.
أحسنت أحسنت.
يومكم سعيد.
ويومكم أسعد إن شاء الله. وبارك
إن شاء الله الجميع يا رب. إن شاء الله.
إن شاء الله. كل السلامة. يومكم إن شاء الله.
أراكم على خير بإذن الله.